Hi, we're going to go over a couple questions regarding the hyperbola. So before we introduce those questions, I thought I'd take a few minutes to go over some vocabulary that's important. So what you see here is a picture of a hyperbola. So this curve here and this curve here make up the points on the hyperbola. And then we have some symmetry going on. So there's a center. Then we have two vertices coming off the center. And they come off the center using this transverse axis. Now we're going to learn about a vertical transverse axis and a horizontal transverse axis, but you could also rotate these so that they're not vertical or horizontal. But we're only going to focus on vertical and horizontal. They also have these foci. The foci lie inside of the hyperbola, inside of this curved part of the hyperbola. So you need to be able to recognize these different features of the hyperbola. We also have these asymptotes, these slant asymptotes or oblique asymptotes that occur, and these asymptotes guide the end behavior of the hyperbola going towards that asymptote. So over here I have some equations of hyperbola, and remember I said we're going to focus on a horizontal transverse axis and a vertical transverse axis. So the picture I'm showing you here is a vertical transverse axis. So that transverse axis is the equation x equals h. And the equation is y minus k squared over a squared minus x minus h squared over b squared equals 1. So there are a lot of different variables there. So let's take a look at what these mean. We have k and h. And K and H are the labels that we use for the center. So we do H comma K. So H is the X. You can see that H is over here with the X. K is the Y coordinate of the center in the Y part of the equation. And then we have these A and B. So let me show you the A, B, and C on this picture. So A is going to be the distance from the center to the vertex. So going from the center to the vertex, I'm going to label that as A. You could also label this distance here as A from the center to the other vertex. Remember, we have a lot of symmetry going on here. Then we have C. C is the distance from the center to the focus. So this distance here is C. We could also label this as C, the center to the other focus. Then B is a little bit harder to see on this picture. If I go starting from this vertex horizontally across to the asymptote, this distance will be B. Now the reason why we label this as B, if we take a look at the asymptote, the slope of the equation of the asymptote is A over B. So remember, we think of that as rise over run. And so that's why you see this vertical rise and then run of this asymptote, the equation of the asymptote. Now, as it turns out, with a little bit of manipulation, you can also see that this distance here along the asymptote is also C. And so we have a right triangle, which means that we can use Pythagorean theorem to relate the A, B, and C. So this is all helpful information when we're trying to take pieces of information to build the equation of the hyperbola. So the key points, just a reminder here, are to be able to label this information. So you want to know this vocabulary of center, vertex, focus, asymptote, and transverse axis. And then you should also know that A is the distance between the center and the vertex. C is the distance between the center and the focus. And then we're going to get B using that asymptote. Okay, so I have an example for us to work out. We want to find the equation of the hyperbola described, graph the equation, and the hyperbola that's described is having a foci, two foci, at 0, -12, and 0, 12. We're also given that one of the asymptotes is the line y equals -x. The first thing that I like to do is to figure out the orientation of the hyperbola. And that's important because, as you saw earlier, we have one equation that represents a vertical transverse axis and a different equation that represents the horizontal transverse axis. So I want to be able to start with the right template. I need to know the orientation. So to figure out the orientation, I usually start putting the information given on just a really rough sketch of the picture. So if I have foci at 0, -12, 0, -12 might be around here, and 0, 12 maybe be around here. And then I have y equals -x as my asymptote, which would be a line just about like this. Negative slope passing through the origin of 0, 0. So based on this information, I can tell that we have a vertical transverse axis. So let me just remind you of why I know that to be true. So when I have a vertical transverse axis, my center, vertices, and foci all lie on that vertical line. And then the parabola uses the hyperbola uses the vertex as a point on the graph. Whereas if we have a horizontal transverse axis, the center, the vertices, and the foci will all lie on that horizontal axis. And once again, we would use that vertex as the point that's on the hyperbola. So you can see here, because the two foci are on the same vertical line, then I have a vertical orientation or a vertical transverse axis. So we know we have a vertical transverse axis. So let's write out the equation. That's going to be y minus k squared over a squared. And this is going to be a minus right here. Hyperbola has a minus in the equation. We have x minus h squared over b squared equals 1. So now that I have the right template, I want to start filling in pieces of information. So the first piece of information that I want to figure out is involving the HK. So you'll recall the HK is the center. Now looking at our rough sketch over here, I'm going to place the center right here at the origin, 0, 0. We have a lot of symmetry going on with that hyperbola. And so I've got 0, 0 in the middle or the center of the two foci. So we've got a positive 12 and a negative 12, meaning that center has to be at 0, 0. So I know that H and K are 0, 0. But the center is 0, 0. And now I can rewrite this equation, y squared over a squared minus x squared over b squared equals 1. So continuing on, I want to try to identify what the a and the b are. This is going to be a little bit more difficult because of the information that's given. So remember the three letters, A, B, and C. A is the distance between the center and the vertex. C is the distance between the center and the foci. And B comes from that asymptote. So in our information here, we're given these two foci. The distance between the center and the foci is going to give us the value of C. So I know that C is equal to 12 based on that given information. I want to find the A and the B. So as I said, it's a little bit more difficult because the only other information that we're given is this asymptote. So with the asymptote, what we have to keep in mind is that the slope that we get, that slope is going to be A over B in the vertical orientation. It's B over A in the horizontal orientation. So if I look at the slope, A over B, of this line, I get -1. So the slope is -1. That means A over B is -1. And so A is equal to -B. I get that if I multiply both sides by B. Since you have two asymptotes, the other asymptote would be y equals x. So we could also say A is equal to B. Now, I know that A is equal to B, but that doesn't tell me what A and B are. So I'm going to use that Pythagorean theorem that we talked about earlier. A squared plus B squared equals C squared. I've already found that C is equal to 12, and I've just found that A and B are equal to each other. So I'll write 12 squared. And instead of writing A squared plus B squared, I'm going to write A squared plus A squared. And A squared plus A squared is 2A squared. 12 squared is 144. I'm going to divide both sides by 2 and get A squared equals 72. And I will square root both sides. A squared equals square root of 72. That gives A is equal to square root of 72, and that means B is also the square root of 72. So now I'm able to finish writing that equation. Remember, we had y squared over A squared minus x squared over B squared equals 1. That's y squared over square root of 72 squared, plus, not plus, that's a minus. minus x squared over square root of 72 squared equals 1. And the square root and the square cancel each other out. And so we have y squared over 72 minus x squared over 72 equals 1. I'm going to draw the final sketch of this graph using the information that we have. So let's say I've got my foci here at 0, 12, 0, negative 12. I know I've got my asymptote The only other piece of information I want to do is use my calculator. I'm going to use my calculator to find the square root of 72. That's what A is. So square root of 72 is just a little bit less than 9. It's close to just a little bit less than 8.5. So that would be about right here. I'm just estimating, and that tells me where my vertices are. And then from there, I'm going to go from my vertex and start following the asymptotes to draw the rest of the picture. So there I have a sketch of my hyperbola. So now we're going to try this application problem for hyperbolas. The cross-section of a nuclear power plant's cooling tower is in the shape of a hyperbola. Suppose that the tower has a base diameter of 168 meters and a diameter at its narrowest point of 72 meters above the ground is 56 meters. If the diameter at the top of the tower is 112 meters, how tall is the tower? So it's a little bit confusing at first. So first I'm going to draw the shape of the cross section. So that cross section of the tower, remember, it's in the shape of a hyperbola. So I'm going to draw the tower like this, as a hyperbola would look. And we know that the diameter at the base of the tower is 168 meters. And then at its narrowest point, it has a diameter of 56 meters. And then at the top of the tower, it has a diameter of 112. And it also mentions here that this narrowest point occurs 72 meters above the ground. So I've drawn a quick sketch here, and now I'm going to try to translate this into details that will give us the equation of the hyperbola. So if you'll remember, we have a horizontal orientation of hyperbolas, and we have a vertical orientation. With the horizontal orientation, we have our horizontal transverse axis, and that has a center, vertices, and foci all falling along that horizontal line. And when we have a vertical transverse axis, we have the center, the vertices, and the foci falling along in that vertical orientation. So we've got our narrowest point here between those two pieces of the hyperbola, helping us to identify this as our narrowest point and these 2 points as our vertices. So because our vertices are falling in this horizontal orientation, I'm going to draw the hyperbola with this horizontal orientation. So with our horizontal orientation, as we mentioned here, we have a distance at that narrowest point of 56 meters. I'm going to choose a center of 0, 0. We could choose a different center, but so that we can keep the equation as simple as possible, I'm going to choose a center of 0, 0. And the distance here along that center part we know is 56, so half of that will be 28. So this vertex would be 28, 0. This one would be negative 28, 0. Okay, so then if I'm writing some other ordered pairs here that are helpful, since the diameter at the base is 168, I know that half of that will be on each side. So half of 168 is 84. So that means that these two ordered pairs are going to be, let's see, 84 and negative 84 for the x's. And then for the y, we've got this height of 72. And so that means I'm going to go negative 72 for the y coordinates on both of those. So then I'm going to write the ordered pairs at the top here. Now the y coordinate we don't know. It doesn't give us any information about how high that top part of the tower is, and that is the main goal of this question, is figuring out that height. So I don't know what the y coordinate would be at those 2 points, but the x coordinates, I'm going to do half of 112, which is 56. So we have a positive 56 and a negative 56. So this gives me a little bit better picture. Now, because I've chosen the center at 0, 0, I know that HK is 0 and 0. So it's going to make my equation a little bit easier. So the equation is going to be x squared over a squared minus y squared over b squared equals 1. So figuring out this a and b is going to be the key to solving this question and answering how tall the tower is. So using my picture, I'm already able to say what a is. A is the distance between the center to the vertex. So I know that a is 28. That x squared over 28 squared minus y squared over b squared equals 1. And since b is unknown here, what I'm going to do is I'm going to choose one of these ordered pairs. You can choose this one here, or you can choose this one here, either one. I'm choosing ordered pairs where I know both the x and y, and I'm going to substitute the x and y into the equation, and that means that the only missing value is b, and I'll be able to solve for that missing value. So I'll use this ordered pair right here and substitute in for x and y, and I'll solve for b. So x squared, that's 84 squared over 28 squared minus negative 72 squared over b squared equals 1. Okay, so if I work out 84 squared, that's 7,056. 28 squared is 784. 72 squared, that's 5,184 over b squared equals 1. Now 7,056 divided by 784 works out to be 9. And now I'm working to solve for that b. So to solve for that b, I'm going to subtract 9 on both sides. That gives negative 5,184 over b squared. And 1 minus 9 is negative 8. I'll get rid of that negative on both sides by multiplying by negative 1 on both sides. So I have 5,184 over b squared equals 8. I'm going to continue solving for b. And to solve for b, I want the variable out of the denominator. So I'm going to multiply by b squared on both sides. And on the left-hand side, the b squareds cancel. I have 5,184 equals 8b squared. Now I can solve for b by dividing by 8 on both sides. And that gives me b squared equals, 5,184 divided by 8 is 648. So b squared is 648. So going back to my equation, I can now write the equation as x squared over 28 squared minus y squared over 648 equals 1. I'm going to zoom out here and let's just remind ourselves that this y here is going to help us identify the height. So that y is going to be the height of this portion. I already have the height of this portion being 72. So if I find the top portion's height, I'm going to add that to the 72 for the total height of the tower. So I'm going to use this ordered pair and substitute it into the equation and solve for y. So that gives 56 squared over 28 squared minus y squared over 648 equals 1. Okay, 56 squared is 3,136. We already saw earlier that 28 squared is 784. So 3,136 divided by 784 is 4. And I want to solve for y. So to solve for y, I'm going to subtract 4 on both sides. I have negative y squared over 648 equals negative 3. Get rid of that negative by multiplying by negative 1 on both sides. That gives y squared over 648 equals 3. I'm going to solve for that y squared by multiplying by 648 on both sides. I'm multiplying by 648 on each side gives y squared equals 1,944. And I'll square root both sides. I need to know the square root of 1,944. So that gives 44.1. So let's go back to our picture. So this y right here, we got to be 44.1. We're going to add that to the lower part of the tower, 72 plus 44.1. Gives me a height of 116.1. The height of this tower is 116.1 meters. Thank you for checking out my videos. Have a great day.